Hey guys, welcome back to the channel. Today I'm going to show you how to solve for this electrical circuit. The first thing you should know is this triangle right over here. And this triangle will help you remember all the formulas for the current, the voltage and the resistance without knowing them by heart. So if you want to calculate voltage, it would be V equals I times R. And if you want to calculate R, it would be V divided by I. And for I, it would be V divided by R. Another formula you should know is for series resistance, and this is simply just you add the resistance to each other and so forth until you get to the amount of resistors that are in series. And for the parallel resistance, this would just be simply, it's a bit more complex, would be 1 divided by R1 plus 1 divided by R2 and so forth. And you have to inverse it. This is very important, the inverse, to get the resistance that you need. Now, for this circuit over here, let's start with this leg of the circuit. And we know they are in series, so our series 1 equals R3 plus R4. And this is 25 plus 15 ohm. And the total is 40 ohms. And now for the next part, we want to simplify this leg over here. And we know that they are in series with one another. So our parallel 1 equals 1 divided by R1 plus 1 divided by R2. In the inverse of it, of course, as you will remember. So it will be 1 divided by 5, plus 1 divided by 10, and you take the inverse of this, and this will be 3.33 ohms. Also just remember if they want it in 2 decimals or 3 decimal points, that's also a key thing to remember. Now that we have those parts, we can simplify the circuit even more. And this would just simply be this resistance and this one over here. So this is R series 1 and this is R parallel 1. And we also know that these two are also in parallel. So R1 and this one is all in parallel with each other. So R parallel 2, which is basically the total, is 1 over RS1 plus 1 over RP1, the inverse of it of course, and this is simply 1 over 40 plus 1 over 3.33, the inverse, and this is equal to, let's just calculate that for a second. .074 ohms. Whoops, a bit cut off over there, but you get the point. And this is the total. Now, let's say you want to get the total, the total current. The first thing you need to know is, of this we know that its current equals V divided by R. We have this and we have this. So I total will be the 100 divided by the 3.074, which is equal to 32.53. 2.53 amps. I also just forgot to write the formula. Always write your formula. So this would just be V divided by R. Remember to write your formula so you don't confuse yourself like I did over there. So the next part is, let's say you want I1. So I1 is also another current, but because they are in parallel with each other, this current plus this current will equal the I total. Now, if you want to get I1, we have the voltage, because the voltage here will be the same as the voltage here. That's just one of the rules for parallel resistance, that the voltages will always be equal in both of these legs. Now, I1 equals V1 over RP1. Therefore, the voltage is 100 volts divided by 3.33 ohms, and this will be 30.03 amps. Now the next part would be for I2. Follow the same rules over there. So I2 equals V2 equals RS1, since these R3 and R4 are in parallel, or in series, with each other, and we already calculated it over here. So 100 divided by 40 ohms, and this equals 2.5 amps. And if you add these two together, you will get roughly the same amperage as the I total, which is 32.53 amps. And this is equal to each other over here. Now the next part of this is to calculate the voltages. So if you want to calculate the voltage on resistor 4, which is over here, we know that there will be a voltage drop over here as well. So the voltage over R3 plus R4 will equal 100 volts. Now, VR4 will equal IR4 times R4. And we know that because R3 and R4 are in series with each other, their currents will also be the same. So IR3 equals IR4 equals 2.5 amps. So this is 2.5 times R4 is 15, and this is 37.5 volts. And if we want to calculate for VR3, we would simply do the opposite that we did over for VR4. Or we can just do a simple way, which is VR3 equals 100, or V total, V supply rather, minus VR4. This is 100 minus 37.5 is 62.5 volts. So we have the voltage over here and we have the voltage over here, and this R3 plus R4 will give you the same voltage as R supply over here. Now, let's say we want to calculate, let me just clear some of this up over here since we already have most of this. Now, let's say we want to get IR1. So IR1 would be V divided by R1. And we know, since I1, we already know I1, so R2 plus R1 will equal I1. And the voltages over R1 and R2 would be 100 volts. So it will be 100 divided by R1, which is 5, and this would equal 25 amps. Sorry, 20 amps. bit rusty over there, sorry about that. 20 amps. And IR2, you can do it the same way. So it's V1 divided by R2 is equal 100 divided by 10, and this would be 10 amps. And if you take these two together, it will be 30 amps, the same as we calculated it over here, roughly, give or take. Now, let's calculate for powers. Let me just clear this away again. Let's say we want to calculate the powers in the parallel resistance. So the power is equal to I squared times R. This is also another formula you need to remember. You have to learn these by heart. There's no easy shortcut to do it. So if you do that, it would be I1 is 20 amps times 2 times the resistance, which is 5, and this would be 2000 watts over R1. Now, if you want to calculate P over R2, this would be the same, which is I R2 squared times the resistance R2, and this would be 10 times 10, and this would be 1000 watts. And if you add these together, we'll know the R parallel wattage, and this is simply 2000 plus 1000 is 3000 watts. Now let's go over to R3 to calculate the wattage over there. We have PR3, and this is simply, we have I2, which is this 2.5 amps. So we can also use another formula over there, which is the same, which is PR3 equals IR3 squared times R3, and this is 2.5 times the 25 ohms, which is 156.25 watts over R3. Now PR4, we can do the same formula, which is IR4 squared times R4, which is the same, 2.5 times 15, and this is equal to 93.75 watts. So P series 1, and this is equal to 156.25 plus 93.75, and this will equal 250 watts. So therefore the P total, this would just be simply that P for the parallel plus P for the series, which is simply that 3000 watts plus 250 watts, and this would simply be 3250 watts for the total resistance. I hope you guys learned something today about solving this circuit over here, and hopefully you'll just remember that these formulas over here is basically what you need to solve for any electrical circuit. And of course you have to just remember the power